Dear students, welcome to the first lesson in mathematics in class 10. You all know about number systems up to class 9. You are exposed to natural numbers, whole numbers, integers, rational numbers and irrational numbers, and together we call them real numbers. You all know that. In this particular class, we are going to learn two important mathematical concepts. One is Euclid's division lemma and the other one is fundamental theorem of arithmetic. Remember, to learn the first concept, Euclid's division lemma is a new word, but you need not worry. Lemma means it's a statement which is already proven, which is used for proving the other mathematical statements. Now, before we learn that particular concept, let us learn about division. Why division? We all know right from primary classes. But we need to learn about division again. Let us take two numbers. For example, say 14 and 8. You can divide 14 by 8 this way. 14 is taken, 14 is the dividend, 8 is the divisor. Now we are dividing 8. One time it can be taken away from 14, and which gives you 6 as the remainder. Now this 14 is called dividend and 8 is divisor, 1 is the quotient and 6 is the remainder. So we can project this particular fact this way. Dividend is equal to divisor into quotient plus remainder. Right? This is what we learned in the lower classes called division algorithm. That is, dividend is equal to divisor into quotient plus remainder. Okay? And this particular division algorithm very formally known as Euclid's division lemma. That is, let me explain. Take any two integers a and b, then always there exists a relation between a and b like this. For any two integers a and b, there exist two integers and they are unique, of course. Two unique integers, say b and r, q and r, and a equal to bq plus r, and this is known as Euclid's division lemma, where a and b are the integers, and the relation goes like this. Q and r are the fixed or unique integers, where always this remainder is either equal to 0 or greater than 0, and remainder is always less than the divisor b. So even for a and b, any two integers, there exist two integers, unique integers q and r, such that a equal to bq plus r, where 0 is less than or equal to r, less than b. Okay, now let us put this in the usual form. For example, let us take two integers again, say 6 and 5. 6 divided by 5, and 5 1 to 5, 1 is the remainder. Now this can be put like this. 6, the divisor a, the dividend a is equal to 5, the divisor r b, into q, that is 1, plus remainder again 1. Now you may take some more examples like this. For example, now let us take two more examples. say integers 17 and say 3. Let us divide here a equal to 17, b equal to 3. 17 is divided by 3. That means 17, 3 5s are 15 and 2 is the remainder. This is the long division process. When we put it in the form of in the form Euclid division lemma, it comes like this. A, that is 17, is equal to b, that is 3 multiplied by q, 5, plus remainder 2. So a equal to bq plus r. And always remember, this division is a unique one, a fixed one. Therefore, the values here, the q and r are unique. You can't have any other values for expressing 17 in terms of 3. So 17 equal to 3 into 5 plus 2. So we also understood that q and r are unique for the given a and b. So this way, now this is the first lesson for you. Now this way, you take more examples, many more examples like this. How do you taking numbers? The two numbers you take, first divide the bigger one by the smaller one and express it this way. So as I showed in the example. Now, how do you take it? You can play a game for this one. What is that game? Take a textbook, open a page, take that page number. Again, now a smaller number you open again. Divide the first page number by the second page number. This way you can play a game. Or any two, some examples you take, write them like this. Today this is the task for you. Right? And we'll meet tomorrow.